Okay, guys, the next topic of our discussion is rational number and their decimal expansion. As you know, in this series, we are taking class 10th chapter 1, and in my previous video, I have explained about irrational numbers. As I have clearly mentioned that rational number, irrational numbers, and other have a lot of properties and lot of applications, so I am keeping in mind the class 10th, so limiting myself up to the topic which is given in the NCERT books. So in this way, the topic today of our discussion is rational number and their decimal expansion. Here the question arises, what is the reason to convert rational number into decimal expansion? Why we convert this? So also you know the definition of rational number, which is denoted by Q, is as P by Q, where Q not equal to 0 and P, Q are integers. Okay. So rational numbers are of the form P by Q, means fractional terms. Now we can take example for this, as 2 by 5. It is of the form P by Q, and if we convert it in decimal expansion, it would be 0.4. Very easy. So what is the reason, means why we convert this form into this and this form into this? All this have been discussed in my video in the 9th class, the topic bearing rational number and their decimal expansion. So if you want to go in detail in this matter, you can see that video. The topic is rational number and their decimal expansion and class 9th. So in that playlist you can go there and see that video. Right, now come to the point. So the first question, as I asked, why we convert fractional term to decimal expansion? So is this the only way to convert it? But the question is remained with us that why we convert. As you know, the real number contains all rational and irrational. So if you have a fraction, how would you differentiate between rational and irrational? Means how can you say that the particular given fraction is rational or irrational? Prima facie you can see irrationals are like that root 2 and rationals are like that. Okay, but this is not the only way, and this is not the sufficient way to differentiate between rational and irrational. So I am going to discuss this topic in detail. How can you say the particular real number is rational or irrational? So when you convert this fraction into decimal expansion, then you can take help of long division methods, right? Long division method is this: here 5, here 2, and decimal 0 and 0 point, as you know, this is 20, this is 4, this is remainder. This is remainder. It is very important, which can make this type of difference. How I am making a small chart type, and that will help a lot to solve this problem. I am giving heading remainder to this chart as remainder. As we see, this is first example and this may be second one. When I convert this type of fraction 2 by 3, as here I write 3, here 2, and again you see this type of 18, 2, again 6, 18, again 2, and you can do a lot of, right? So what we see that remainder is 0 in first case, right? And in second case remainder is not 0, right? If remainder is 0, then we give it name the terminating, right? What does terminate mean? It means end of process, right? Because you can see if remainder is 0, we cannot go beyond this step. So process is stopped. What process? The process of converting a fraction into decimal expansion, right? So end of process means terminating. You can say it terminating fraction, terminating decimal expansion, so a lot of things you can say. But the second one where remainder is not 0. If remainder is not 0, this is called non-terminating. Non-terminating means not end of the process, means process may be continue up to where? This is the question, up to where? The first in this form is when remainder is repeated, means as you see here, when we divide this by this, you are getting remainder 2 after every step. Means this may be happened in every step, in second step, in third step, then that is a period. So you will get a block of letter here which is in repeating forms, right? So first here is remainder is repeated, and second option is remainder is not repeated. Remainder not repeated. These two may be called rational. Rational. So a fraction, a given real number, is called rational number when either remainder 0 or remainder is repeated, right? And if not repeated, this form is called irrational. So by converting a fraction into decimal expansion, you can clearly conclude that whether that fraction is rational or irrational, right? So you can say it as rational numbers are those numbers whose remainder is 0 and, or you can say whose remainder is repeated, right? I am writing a note here. Either terminating or non-terminating but repeating, recurring you can say, and irrational non-terminating non-recurring. Clear? Okay. Now, so in this chapter there are 3 theorems given. I will try to explain the statement of these theorems and then application, right? Here proof is not given, so it is beyond the scope of this book. The first theorem says that if x is rational number, what it says, if x is rational number, I will use short form, okay? If x is a rational number whose decimal expansion terminate mean remainder 0, means the rational number whose remainder is 0, then x can be expressed, then x can be written in the form, okay, x can be written in the form p by q, where this q has prime factorization of the form 2 power m and 5 power n, right? Means x is a rational number which has remainder 0, means terminate rational numbers you can say, and so that rational decimal expansion can be converted into this form, matlab fractional form, right? You can convert that decimal expansion into fractional form, then the denominator of that form when factorized, that factorization will be of the form, means some power of 2 and some power of 5. Clear? If you take example of this form, example we can take here, if we have decimal expansion of 0.375, right? We can convert it into this form, fractional form, with this way. So after cancelling, you can say this will be written as 3 by 8, and this 8, if this 8 is factorized, then it can be written as 2 power 3 and 5 power 0, right? So this theorem clearly says that when a rational number, a rational expansion is of the form which terminates, means remainder 0, then when we convert it in the form of fraction, then denominator part of that fractions have prime factorization of the form. Clear? Again I say, if you have any doubt or query, you can ask me in your comment box. Now the theorem second, that is reverse of theorem first. Means this second theorem is converse of first one. What is converse? Here x is rational and terminate form, right? In the second theorem, we will prove that if a rational number is of the form which has factorization of the type, then that rational would be terminating rational expansion, right? I will write something here. If x equal to p by q, right, a rational number, and this is rational, and having and denominator, that is q, have factorization of the form 2m5n, then that rational will be terminating decimal expansion, right? In first theorem, it was given that x is terminating rational expansion, and we showed that q has prime factor of the form. But in second theorem, it is given that x is rational and q has factorization of the form, then it is to be proved that x is terminating decimal expansions, right? Means if we want to check a fraction which is rational and has the form and has the factorization of the form, its denominator has the factorization of the form, then that fraction will be terminating or non-terminating, because I have clearly told you that fractions are of two types, terminating and non-terminating. So if you want to differentiate between that terminating and non-terminating, then you can use this theorem, right? So exercise 1.4 and question number first clearly has many examples of this theorem, because in that question we have to decide whether the given fraction is terminating or non-terminating expansions. So we will use this theorem to solve those questions. Okay. Theorem number 3. What it says? It says if x is p by q form, means fraction, and given that it is rational such that q, the denominator part, has factors not of the form 2m5n, means if q has not factor of the form, then x is non-terminating, repeating. Why it says repeating? Because if not repeating, then it will not be rational, it will be irrational, and we are talking about just rational numbers. So do not get confused in this type. Now using these properties I am trying to solve these questions, but before that uh, I will tell you a point which you can remember, that when I say x terminate, but when it terminates mean after how many steps it will terminate. It can be uh, said by this formula, means if x is terminating, this is journal point, not using in this book. If x is p by q form and terminating, because it is terminating, so q has factorization of the form 2 power m 5 power n, then after this number I am giving it a name k. What is k here? K is maximum number between m and n. Okay, this is k. What is k? Maximum between m and n, means if, because when you convert these numbers into this form, then you will get these digital numbers, and you can easily see that which is greater or less. So we have take greater one, and I will give example for this. If you have example, if you have this type of expression 2 power 3 and 5 power 4, right, then it will terminate when we are taking maximum of this 3 and 4. What is that? That is 4, means maximum number, larger number between these two. So after these 4 steps it will terminate, you will get remainder 0. Okay, so you can take examples of this, and if you want to verify, you can check that. There may be many questions, but this is journal one. Okay, now come to the exercise. Exercise 1.4. Question first. Without actually performing the long division, state whether the following rational number will have a terminating decimal expansion or non-terminating decimal repeating decimal expansions. So first part is, here we see 13 by 3125, right? Because all these are rational numbers, and you can convert it into this one. This can be written as 5 power 5, right? You can take help this process, which we have done it in our previous or smaller classes, and as you see, it can be written as, and again as, and again as, and again as, right? So this can be written as 5 power 5 power 5 and 2 power 0, right? As we see, this denominator has prime factorization of the form has factorization of the form 5m 2n. So by that theorem by theorem first, so it is terminating, right? I am taking example of a non-terminating form, then that is example question number 5th, and that 5th part is 29 by 343, and you can write it as 7 power 3. And here you see, what do you see? Its denominator is not factorized in the form, so non-terminating, right? This question has 10 part, and we are just to tell whether the part is that question is given, that question is whether it is terminating or non-terminating. So you can see and check, these are very easy ones. Now I am taking question number 2, and the question number 2, write down the decimal expansion of those rational number in question 1 above which have terminating decimal expansions. So we have to take values from question 1 and make solution for question 2. What question 2 says? As we see the first part which is given this, it is terminating decimal expansions, and we have to convert it in decimal expansion. How? Without actual division. So first you have to convert it in this form. Now as you see, we have not any factor of 2, so you can write it as 2 power 5, divide and multiply by this. Why? Because you know, if any fraction, so we can use a word here, equivalent fraction. Equivalent fraction. What is that? If you have 2 by 3, then you can divide and multiply it by any number. You will get this number. Okay, so this number is called equivalent fraction of this. Means 10 by 15 is equivalent fraction of 2 by 3, right? So we are making this topic is in the 9th class, and I have explained it in better ways there, in more explanation, with more explanation and examples. Now here we are making it as equivalent fractions by divide and multiplying by this number. Why? Because if you have a fraction of the form 2 by 10, then you can easily convert it in decimal expansion. So I am trying to make this type of number here, and for that you have to keep in your mind as this point, because if the power of these two numbers same, then it can be written as common power. Means we can multiply these base and power will be common. I have also this explained very well in 9th class, and I will try to link that video if you want to go in deep to this point. Okay, so multiplying this, you will get 13 to the 26, 3 the 39, and 2 4 1, and you will get this number 5 times 0, right? 2 2 4 1 1 5. Now you have to convert it in decimal. As you know, 1 2 3 4 5 zeros, so after 5 points from left to right to the left, 6 1 4, you must use 0 0, so you have 5 digits, and then decimal because you have 5 zeros, so it is decimal expansions, and you can convert it in this way. Very easy way. We can take more example from this. The second part, 17 by 8, you can write it as 17 divided by 2 power 3. So what would be equivalent fraction of this? As we have to multiply it 5 3, and so we will divide also. You will get 17 multiply 1 to 5 and 10 power 3. This is 2125 divided by 3 zeros, and you will get this 2125, right? Another example you can take, fourth part of this, that is 15 by 1600, and you can make it as 2 4 and 10 power 2, right? But as you know, we need 5 power 4, means you have to multiply and divide by this number 5 4, right? And you will get 5 4 is 625, and this will be 10 power 4, and now multiplying this, you will get 7 5 37 and 93, and this would be 2 plus 4 6 zeros, right? And you will get 6 digits before after decimal, so 1 2 3 4 5 6 decimal and 0, right? So question number 2 is very easy, and you can simply do it. Now come to the question number 3 of this exercise. The following real numbers have decimal expansion as given below. In each case, decide whether they are rational or not. Means we have to classify it as whether it is rational or irrational, and given number is this 1 2 3 4 5 6 7 8 9. As you know, as it is terminating, because after 9 nothing is given, so it is terminating, so rational, right? Now you can take question number, second part of this question, that is given as 0 1 2 0 1 2 0 0 1 2 0 0 1 2 0 0 0, and so on. Here you can easily see that it is non-terminating, non-recurring, right? Because nothing is repeating, so not rational. A number which is not rational is always irrational number, right? Then question number 3, and given that 4 3 1 2 3 4 5 6 7 8 9, and this is bar. This bar means it is repeated digit, block of repeated digit you can say, because after this block will completely repeat. So as it is non-terminating because remainder is not 0 but recurring because block is repeated, remainder is repeated, so it is a rational number. So exercise complete, and also the chapter is complete. And I again say, if you have any query or any problem or any doubt, you must ask your query in comment box, and I will give answer to that. So please subscribe our channel and also click on bell icon to get latest video of our channel. Please inspire us by clicking on like icons. If you have any questions like that. Okay, thanks. Chapter is complete.